in Google.
Or maybe another way would be to just Control D on Clang.
Control?
And then go to the window, Control D on Clang.
Yeah,
and then go to the right window and just copy paste it from the examples that are given.
That's what I used to do in another computer that didn't have that.
Yes, but I realize it is a little bit problem for Mac users. It's a nightmare. It's a nightmare.
If you want, Michelle, I can share the screen and help him a bit.
Okay.
Okay.
Can I share the screen?
Yeah, now you can.
Okay.
And also now I start recording just to go to the class of service.
Are you seeing my screen now, LM?
Yes.
Yeah, we're seeing your screen.
You go to Google. Wait a minute. Analytics.
Yes.
And for example, I don't know exactly how to name this character, but for example,
tilde. Exactly. Yes.
And you go, for example, to Wikipedia.
Well, but you're in Spanish. Tilde goes for the, you know.
But for example, this one.
This, yes. I can copy it.
I copy it.
Yes. Okay.
And I go to Super Collider.
Yes, and paste it there. Okay.
Yeah, obviously.
Λίγο μπακαλίστικο, αλλά.
It's there.
Obviously that works, but I don't think that's the most elegant solution.
Okay, I know it's not the best.
Mauricio,
not the best solution,
thank you. Mauricio, thank you. Yes, but
maybe you should look for it as it's also called new flow. That symbol. Maybe if you search it as new flow, you would find the key combination. Are you on Mac or on
Mac? I have Mac. It's a MacBook Pro and with Mojave.
Okay, and if you press the Alt key and the key that is before the number 1 or shift.
Yes, Alt key option. Yes, don't work. Nothing.
Let me see if I can
yes.
New flow. New flow.
Okay, I think it's a problem. It's not good time to we want to start the lesson. I will search it. I have my son here who is a programmer, and he will help me tomorrow. Okay.
Have you tried Option plus N?
Pardon?
Have you tried Option plus N?
Option plus, yes, but Option plus N. I see the upstairs tilde.
Oh, okay.
Yeah.
Yes, I tried. You know the small one tilde upstairs from a letter, for example.
Okay, yes. Okay.
Yes.
Yeah.
Doesn't matter. I will find it.
Okay. If I find a solution, I will let you know. Also, the good news is that we're not going to use neither of those tildes today, because the
Michelle,
code...
I have a question.
Yeah.
Do you remember the?
Yeah. Actually, I ended not answering you because, well, you are using routines and loops, and okay, it was a good way, but actually, a better way to solve what you want to do is via p-bines. That is today.
We're going to see it now. Yeah.
Yeah. So maybe after class, maybe you will be able either to solve it or know how to change the question, so I can help you.
Okay.
So yeah, this will help you. So yeah, let's start with the class, just because it's a kind of a big topic.
And Michelle, put the cameras horizontally.
Yeah, now I have it horizontally and now I'm recording, so we're good to go. So, well, today we're gonna see two things, a little bit of introduction to another type of, just an introduction because we're gonna see it today and next class, to subtractive synthesis. And the main topic of today will be p-bines that actually are, well, I call it p-bines, but they are the patterns family. This pattern family basically is the way to build music structures or behaviors, or basically what we call sequenciators, and they can work algorithmically, right? So they're super cool, and I think they're one of the most cool features about SuperCollider. And actually, in my opinion, for if I don't know if somebody else have encountered with the other like popular music programming languages, for example, MaxMSP or Pure Data, that are the ones that actually are like the direct equal to SuperCollider, that are pretty good. Actually, MaxMSP is super good for structures of control where you have like installation and that type of things. But here, in my opinion, patterns are something that Max doesn't have the same way, and in which SuperCollider excels. The way that you can pretty quickly make algorithmic structures with a little bit of code. And for Max, usually that represents like tons of cables and tons of real boxes. So this is one of my favorite parts about SuperCollider and one of the most powerful bands. So it will be pretty cool. So first, let's start with subtractive synthesis. So this one, it's kind of the, well, it's not the opposite, but it's kind of the opposite thinking of additive synthesis. In additive synthesis, we're taking the most simple possible sound, that is our sine waves, and we were stacking up them to make complex or more complex sounds. And that was pretty cool. Just let me look at something here. Yeah, cool. But now we will take complex sounds, like noisy sounds, like noises or recordings or wherever we want, and we're gonna filter them. We're gonna take out part of the spectrum to like carve out the part of the spectrum that we actually want to use. And that's actually the way subtractive synthesis work. So basically subtractive works like their prime tool are filters. Well, filters are like a pretty standard stuff in musical production industry because they are pretty good for mastering and mixing, but they are also pretty good for just synthesis. But because normally filters are like in another part of the mix, but we can use it as a way of produce sound, like synthesis. So for this, we need a complex sound source. So the first one we're going to encounter is the well-known white noise. So the white noise, why we want that? Because in theory, it's the most common and complex sound source we can get. As we can get, it says that it's a Nugent is generator and it's stochastic. So it's going to generate random numbers in a oriented or in an organized way. It says that generates noise whose spectrum has equal power at all frequencies. So it's generating randomly frequencies at the whole spectrum at equal magnitude. So like getting on and off frequencies all over the spectrum. Basically, it's called white noise because a lot of music synthesis theory names are taken, borrowed from music for sound, for color synthesis. Just like I say, so white light is like the combination of the whole spectrum of light. So white noise is the combination of the whole spectrum of sound. It doesn't make any sense in sound because it's not white, but it's now like a standard things that are white noises, like it's the static that all TVs used to make. This also, we usually tend to think like fans and motors and things that are like continuous make white noise. At least that's a way we used to think that. White noise, as you can see, it only has its multiplicator and add argument. So basically, it only works for. It only has like a volume argument. Usually, white noise is pretty loud. So I'm gonna put it like in 0.1 so we can hear it. We all hear that, right? Yeah. Yeah, just to know that I was actually sharing sound. So
What is 0.1?
it's
It's
the amplitude. Yeah, the amplitude. Actually, basically, white noise just only have the multiplicator and the add. Both act over the amplitude. So by default, it's the only thing you can modify. It's volume. If we scope it, this zoom in and zooming out that I was doing, it was just, when I zoom out, it was just to show how that actually the shape of that noise is pretty random. But once I zoom out, it was to prove that even though it's pretty random, the general shape is pretty stable. So that's what it's like a stochastic random generation. So it's pretty random because it's generating all the frequencies at random, but at equal power, like in a stochastic way. So it most of the time is outputting all the frequencies at the same time. And we get that pretty whitish noise sound. Also, even though it's full in the whole spectrum, we usually tend to perceive white noise as a high-pitched sound. Because as humans, we tend to perceive high-pitched sounds as more loud, even though they have the same physical amplitude. Our ears tend to perceive those sounds as bigger. So that's actually why we came up with this other type of sound that is the pink noise. Pink noise works the same way. But pink noise has a different, so pink noise generates noise whose spectrums falls off in power by 3 decibels per octave, which gives equal power over the span of each octave. This is version of band limited to 8 octaves. So the difference between magnitude and power is that magnitude is like the physical size of the waves, and power is like the perception we perceive actually in our ears. So the pink noise, as it goes up to the high frequencies, is losing amplitude. So we start to perceive them as equal. So pink noise is like the rendition of a white noise that actually has the trick of perception that we perceive as equal power through all the frequencies. So let's hear it and see the difference. Now this one. It's a little bit well, less harsh, more stable. It feels like a little bit more warm, let's say, because now this one, as it goes to the higher pitches, we perceive it as more equal. Usually this is more like an stable. I also recently see like a new, I don't know how to call it, like a new trend of people making their mixing and their masters using a pink noise as a reference. I think it's pretty crazy, but I like the idea of just these trends. But well, so now basically what we intended to do, and for this I'm gonna take my whiteboard. And now we're seeing the whiteboard. So imagine, so my y-axis is what you call this, spectrum. So a white noise or a big noise has frequencies all up, stacked up all over the spectrum, happening random at random amplitudes, but they have like general power, so we perceive it as equal. So usually the spectrum of white noise is pretty crowded, right? So it has frequencies all over. So here my lines are just individual sine waves. Obviously there are more than the ones I'm drawing, but just to make an idea. So I have this like really complex sound that contains, in theory, like all the possible frequencies. So what I want to do is I want to filter this to take part of this sound. Imagine I just want to get the loud part. I mean I just want to have this sounding like the low part and take out the high part of the spectrum. So I get a more subtle kind of like the sound of the ocean sound, and that's windy that has the frequencies. So for this, yeah, tell me.
Is that pink noise?
This could be either white or pink noise. But let's say I'm gonna take the white noise and I just want to hear this part of the spectrum.
Michelle, these sine waves are behavior in, for example, in glissandus as well.
Well, it looks like I draw glissandus. No, they don't. They're more like stacked up.
Okay.
Yeah, it's difficult to write straight lines here without the shift. So sorry about that.
No, because I didn't know.
Yeah, no, actually it's a good question. So basically from this part of the spectrum, that imagine, I don't know, that means that's, I don't know, this is 500 hertz. So I want everything that is built above 100 hertz to stop sounding, all this. And I just want to have the rest of the spectrum sounding. So this is actually usually how filters work. This should be a low pass filter. That is like the most standard type of filter. So basically low pass filter like chooses a frequency just like I did here. This is the cutoff frequency. And it will take out in decibel all this, it will take it out, it will filter it, and it will just let pass what is up below that. So here is what we will have as a result, just this part. And all this part that is above, it will be filtered, this one.
Cut.
Yeah, cut it, exactly. It will take it out and it will just let pass this. Just as, I don't know, like the filter for water acts, you know, it lets pass the water, but it retains some stuff, I don't know, like dirt or minerals, you know, like these filters that used to purify water in your house. So, I mean, I'm telling that because that's like the actual, how you call this, metaphor that is used for filters. So for this, we're gonna use this object called LPF, that is the low pass filter. That is a low pass filter, and basically it says that it's a second order low pass filter, but that doesn't matter for now. It has its arguments, the in, so it needs the input signal, so basically it means what I'm gonna filter. Then the frequency, this is the cutoff frequency, it has to be in hertz. The frequency which will be the pass of the filter. And it says, warning, due to the nature of this implementation, frequency values close to zero may cause glitches on or extremely loud audio artifacts. So, well, first of all, it doesn't make really much sense to put a low pass filter or even a high pass filter. Well, a high pass filter, yeah, it doesn't make sense either. To put it below 20 hertz, because that's the lower the audio here in the spectrum. But even though it says that putting it close to say to zero may cause glitches, And this extreme low audio artifacts that we don't want to hear in our speakers, right? And then it has its multiplication and add that basically is the amplitude control. So I go here, I feed it with a white noise. I will put 500 just like example, and we're good to go. And I'm not hearing anything because, yeah. That's a big difference, right? Start to feel more like the sound of the ocean and like, or something like this, like water, like a cascade or something. That's a lot more warm and low end to the frequency. If I go lower, so this one is cutting everything above 100 hertz. That's pretty cool. So as you notice, this time I use a bigger number. The reason I'm using a bigger number is because I can use more amplitude because I will be cutting a lot of the spectrum, and that spectrum will be taking out frequencies that has amplitude. So basically that will be reducing the total amplitude of my sound. So I can put a higher amplitude and that doesn't affect. If I put 3 here, I can do it, but it will be pretty loud. See, you can even see here that it was super loud. And this one, it's a lot softer.
So Michelle, first you use volume and then frequency, yeah?
And which one?
In the last.
In this one? Well, but,
Yeah.
I
Volume
mean,
and frequency.
yeah, because this is the volume, the white noise, and then the frequency that I'm cutting. You can put volume to the filter itself. Actually, by default, it has a 1. So basically, that 1 will be multiplied by the original amplitude of the white noise.
But the frequency is the filter frequency.
Yeah, because here
So you are filtering 200 hertz to the real sound.
to the input sound. Yeah, exactly.
Yeah, okay.
Yeah, exactly.
Sorry, this cutoff frequency is like in analog filters. I mean, it's the frequency where my input signal decays 3 dB, or is from there on I have no signal.
You can use both. You can use both. I think that this second order is that you don't have that.
No, so it's about the word. Okay.
Exactly,
Okay.
but you can use both filters because if I go here, filter, yeah, there are a lot. For example, this below pass that is a 12D octave roll-off. So you can use a different type of filters. I have these Moog filters. So this one is the second order, so it's filters like from that point you don't have signal.
6 dB.
Exactly. There are actually a lot of filters that you can use.
Yeah.
Actually, next class we're gonna go like more in depth to filters, because today we're gonna go see just some filters, and next class actually we're gonna go to resonant filters that are actually a lot filters that I like a lot.
Yeah.
How did you see all the different type of filters we have, Michel? Like this list, like where did you search for?
I put filter.
Oh, yeah, okay.
Basically,
okay.
if you and it will put every class that has filter in its name or in its first description, in its like in an
got it.
overall description.
Got it. Yeah.
Yeah, I think I will have more than you, because I actually have installed the Super Collider extension pack that we will install in some class, so don't worry about that. But just don't worry if you see, for example, I have like this BMOOG that is a digital description of one filter Moog, and as you can see, it's an extension.
Yeah, I don't have it. Okay.
But we're gonna install like the extension packs, like, so don't worry about that. Actually, the extension packs has a lot of the most cool classes. So yeah, but the topics that I cover in the workshop are just topics that work everything with like the native classes of SuperCollider. And it's pretty cool to know that you can do everything with the native classes, because that also will make sure that every patch that you make will work in every SuperCollider, in every laptop, in every PC. So, because as you start to stack up like individual classes, so for example, one of your friends make a super cool class, it will work, but now you have to install it in every different computer you want to use that class. So, also, isn't that a problem to install class? It's just to open a folder, put insert in the documentation of the class, and there you go. But it's like an extra process. So now I'm gonna copy this and change this to high pass filter. So this is basically the same, but it's the opposite. The frequency, the cutoff frequency acts to the other side. It cuts everything that is below the cutoff frequency, and it let pass the wherever it's above. That's why it's a high pass and not a low pass. So so now here I'm gonna put a lot low, and I'm gonna put 1 here, and I'm gonna put 2000. So I'm gonna just let pass everything that is above 2000 hertz. And now I get a really windish type of sound. It almost sounds, for example, if I get a lot upper, like 10,000, I will get like the sound of air, pressure air escaping from something, like when you have a leak or something. Like really thin. So as you can see, as just applying these noises, these filters at random frequencies, I really change a lot the sound of my original input. These are actually also pretty good for also the bandpass filters we're gonna see in the class, for mixing, because you can make room for other things. Like I don't know, I got a piano that is inside in the middle register of my mix, and I got some percussion that I wanted to be more in front, and the piano is taking a spectral spatium, so I use the filter to take out that part of the spectrum and give room to another of my instruments, something like that. But we're gonna get more in the stuff of making synthesis out of this. So yeah, okay, before going to this stuff, another question regarding this? We're good? Yeah, we're good.
Yep, good.
Cool. So now this is just a like super light introduction to filters, because it's basically one of the main topics of next class. The only reason that I want to use a little bit of introduction is that we can use a little bit of this to make some sounds that we can use today with the P-Vines. That is actually the main thing. So let's make, using these filters and white noise, let's try to use this to make a sound. I want to make, yeah.
Michael?
Yeah, of course, that's Fotis, right?
Yeah.
Yeah, now I'm learning your voices.
Is there like an equalizer using?
Like in a band's spectrum?
Yeah, where you can, it's like multi-band, and you can choose which band to tweak.
Yeah, I'm pretty sure. Yeah. This is a parametric equalizer, and
okay,
let's see this one. And I know there's another one. No, because this is center frequency. No, this is not the one that I want to show you. After class, I'm gonna search for the one that I want to, and I will show you. Because there's a really cool one, but I don't remember its name. But this, you can work with bands, more like a normal equalizer. Also in the newest SuperCollider, actually I don't have that one, in the 3.11, there's also a new object that you can use that is called BST plugin, where you can open BS plugins inside SuperCollider. So that's also pretty
really?
cool. Yeah.
Nice. Yeah.
Yeah. I'm gonna do it in the future. So maybe I can show you by the end of the workshop. I'm just a little bit, I don't want to like, because sometimes when you upgrade SuperCollider, maybe some things stop working. So it will take, it's just that I don't want to do the work, but it's pretty simple. So, well, that's a good question. Next class, we're gonna see bandpass filters and resonant filters, and I can show you that equalizer you want. So today, now I want to make a percussive sound. So we can have some percussion to work with the sequentizers, P-Vines. So I want to make a snare drum. Something easier. What is snare drum? Because a snare drum has, well, they have their snare, and that snare is pretty noisy and high pitched. It's like if I try to imitate the sound of a snare drum, I make that sound. So white noise is a pretty good input or a pretty good sound source to start making up a snare drum. So I go here, arguments, variables. So I will call this input. Also, so we start to go through again to SINDEF. So input equal white noise. So I'm going to use my white noise as my main source of sound. There we go. Then I want to put here signal, my actual signal, that it will be my sound, but passing through a high pass filter. In, I want to put input, and as the frequency, I want to use 10,000, just to get a really type of sound. Obviously, this will sound just like this, right? So I need to be this percussive. So an envelope will help. Envelope, I go M generator in control rate, and then I use m.perc. Remember that m.perc just asks for attack time and release time, because it's pretty assuming that percussion envelopes are just like this, right? Just attack and release. And I just want to, so attack and release will be pretty cool like this. Even 0.5 to make it slower. I have the mic, yeah. There we go. Sig equals sig times envelope. Then sig equals, remember this object that I showed you, pan2, just to make it stereo. And we're good to go. Obviously, this isn't my final sound, but it's like the first intention, and let's see how this sounds. I don't have arguments, so I can take this out for now. So I get that part that I wanted, but to me, it still doesn't sound like a snare drum. So to sound like a percussive, or at least a skin, drum sound, what I'm missing? What part of the sound did you think I am missing? Just like a guess.
Impact.
Exactly. Somebody saying impact. Who was that?
Yeah.
Cool. Yeah, exactly. The impact. I'm missing the part of the mallet hitting the skin of the instrument. Well, that's a name in English. The skin, like the plastic thing.
Membrane.
The membrane. Yeah, perfect. Yeah, because in Spanish we say parche, but yeah, membrane. Yeah, skin is more like for a djembe or for like instrument that actually uses animal skin, right? So yeah, for the membrane, that impact of the mallet, it's important because snare doesn't sound they sound ta, ta, ta. So they got the ta and the at the same time. Now I got the sh. So I will build the ta, the impact. For that, I will use something very simple. So I will add a variable called impact. Also, I'm trying to show you this to show you that usually to make good sounds, you have to use more than one type of synthesis and more than one sound source combined. This will be simple, but it will. So I will use a Synos, super simple, at 120 hertz to just make a low. And then, yeah, please tell me.
Under of a snare drum have some strings.
Yeah, you mean the snare itself, right?
Under, yes. So when it impact the strings, make that no strings.
Yeah, that is the white noise. The part that
yes, from strings.
Exactly.
Yeah.
Yeah, it wasn't. Yeah, I think that was called snare, like this metal stuffs. Yeah, but yeah, we're in some place, and I will put its own envelope M1 to the impact because this envelope belongs to the white noise. So I'm gonna use this one. But I will make this a lot shorter, a lot faster, to be a really short impact. And then here I will put impact equals impact time envelope. So it has envelope 1, so each one of them has their own envelope. And here, before passing it through the stereo stuff, I will put that sig equals sig plus impact. So they are outputting in additive synthesis. So basically this part is subtractive, this part is just a sine wave, and this part is a additive synthesis. So now let's hear it. Why did I not like it? M1, okay, I didn't define M1. Now she should work. And now I have it a lot better. It's not the best. I'm gonna put here a little bit more of less amplitude.
Perhaps release of 0 at the line 5. Release it's more longer, not to 0 15. Yes.
Yeah, this is better. This sounds a little bit drummier.
Yes.
It's not the most elegant sound, but don't worry, we're gonna go to best sounds.
Maybe also higher frequency for the impact, a little bit higher. Maybe that would work.
Yeah, let's see, like maybe 320. Let's see if that's not too much. Yeah, it's too much.
Yeah.
But 220. Oh, this sounds like a smaller snare. I like it.
Lower, perhaps 150.
160, yeah. That's better.
Yeah.
Yeah, it's
Cool.
better.
Yeah, sorry, Michelle. Is there a way in Super Collider to make like a sync of oscillator? You know, like mathematically will be the sinus of the time divided by the time itself. I don't know, maybe.
I didn't get it. Can you repeat the question?
Yeah, because you know, in signals and systems theory, when you want to like reproduce, you have the spectrum, no, of the white noise, or you have a step spectrum, we could call it, and the approximation, if you not cover the whole spectrum of frequencies possible, is like mathematically is not exactly like a sinus, but it's kind of like a sinus that is decaying, has like an envelope, like an exponential envelope. You could say it's not exponential; it's more like linear, but well, it's a function that is called sinc, like SI.
But what you want to affect is the envelope shape.
Kinda. Let me Google it.
Yeah,
but-
because I'm pretty sure the answer for your question is yes, because
Yeah.
that's usually the answer with super glider, but I'm not fully getting the question.
No, I was trying to like reproduce a waveform, but I'm looking.
So you to use a waveform for a envelope?
The waveform would be like the sinus function, but sorry, the waveform would be the sinus function, but the envelope is like an exponential one rather than a really short step.
Yeah.
mean, a really short linear. I mean.
Yeah. I can shape this.
Like a wave cycle, maybe? I don't know.
I can shape the type of curve in the envelope, and even with MNU, I can shape, like, for example, let me show you. I'm not sure if this will help, Bolt.
Because if you take the Fourier transform of you say like you make an impact is like really close supposedly to an impulse, and the spectrum of the impulse is kind of like the white noise that it has a linear spectrum over the whole range of frequency. I mean, you make an impact, and the spectrum of the impact of a pure impact, like
like a click, like a noise.
Yeah, like I cannot remember, like a delta is Dirac's delta. I don't know if anyone is familiar with. The spectrum of a Dirac's delta is like a constant one in the whole spectrum. And if you don't take the whole spectrum, and then you like calculate the anti-transform of that, like not whole spectrum, that would look like a step, you know, like un escalón.
Yeah.
A one till suddenly it goes to 0. In spectrum like that, it gives you a signal that it could be represented as sinus of x, with x being the time, divided by the time itself. Like the longer the time, the smaller the amplitude.
Okay,
Yeah, it's like super collider.
Yeah, you can do that in super collider. Yeah,
it has like a shortcut for that.
No, well, first of all, we can do it like directly with the function and mathematics, but I'm pretty sure there's a shortcut for that, because super collider has a whole group of classes that work with Fourier.
Great.
As you can see, there are like ton of things like FFT, FFT peak, FFT crest, FFT slow power. So I'm pretty sure one of these FFT does that by itself. Outputs the necessary signals for FFT 10s without doing the FFT. Yeah, so this will, I'm pretty sure FFT will do that. I would like that. Yeah. I would like that you can repeat that maybe in the chat, like in the chat, in the PN.
Yeah, no problem.
And also, you're a native Spanish speaker, right?
Yeah.
So yeah, also write me in Spanish. That will make it easier for us.
Great.
Yeah, and maybe that will help me to understand and show you the correct way for that.
Yeah.
Because it's a little bit more technical. And don't worry, I'm good at this technical stuff. Usually, I try to avoid that level of mathematics in the workshop, because it's like musician same, not so like program same. So, but I like it. It's a really good question. So I will try to do that. So repeat that in. Cool. So for now,
this was oriented only because impact I associated with impulse.
Yeah, I like it. I like it. Also, also SuperCollider has like an impulse generator.
Oh, great.
So maybe, yeah, just maybe if this help. I also this one is part of the next class object, so don't worry. It's okay if I show you this.
Great. Yeah.
Yeah, and it also has like this another one that does this, but in a more random distribution. So yeah, we're gonna see through this next class. And well, also I will try to do what you say. So cool.
Thanks.
Don't worry. Like okay, so we got like a really like a really simple, not so cool sound snare. Well, this is snare that we make with the. Also, we make this snare with only the objects that we already know from the last two classes and the new one. So that's cool. Obviously, this needs a reverb and other stuff, but we're gonna avoid that for now because we're gonna see effects in another class. So don't worry about that. Like reverb that usually is treated as an effect and not so much like as a quality of the sound itself. And that's because usually sound sources are separated from the reverb because reverb has to do with space, not with sound source. So that's why it's an effect and not a property of the actual sound. So we have this. I like it. It sounds pretty snare-ish for me. Like those snare that were pretty. If I put like a lot of reverb in it, it will sound like the snares that they love to use like in the 80s. So
Michelle, if you put more decibels to the complete program, then you have maybe a more effective impact.
but you more decibels to
In line 30.
you mean
If
here?
Yeah, if you change the mood.
Yeah, at first I had more mold, but for me it was too aggressive. But let's see. That sounds cool. Also, I will put 0.8 because I don't like to use the one. Usually one is not recommended. So yeah, so let's take the break now. And after that, we're gonna start with patterns. That is like one of the main topics that I want to see. So let's see you in 10 minutes.
Okay.
Hey, I'm back. Please tell me when we are most of us back.
Michel, just a quick question before I come back.
Yeah.
So not really related to SuperClavier, but more like Jerry, related to how to synthesize a snare. So is that the what we just did using a white noise and with like the impact sign that we added? Is that the generic way of doing, or
No. If I wanted to do it like a more robust,
I was more thinking about, because when you do like a kick drum, for example, like you tend to put some higher frequency at the, at the beginning.
yeah,
And
like,
so
also that's like the standard for kick drums for like today, like they do like boom, boom, like this,
so
that pitch
you have
bend,
two
right?
envelope. Yeah, you have an envelope for the amplitude and one for the frequency.
Yeah,
So,
also for snare drums, I will, instead of using the like a plain sinus that I just hear, I will use FM synthesis. Because with FM synthesis, I can,
okay.
yeah.
Oh, okay.
Because with white noise, you will always get like the same type of snare drum, and with FM, you can get a lot of variances of different snare drums.
And is it something similar to, again, I'm not very knowledgeable in that, but is it something similar to like a kick where, for a snare, you would need to have like, kind of higher frequencies, at the very beginning and kind of, just letting them go as it fades away or something like that?
Yeah, that will also help, like toof, toof, toof.
Exactly. Okay, so that's what we're not really doing that.
No, because it was just a really simple, and I was using like
Okay.
Also, class 5, our class 5 will be about FM synthesis. Actually, that's like my favorite type of synthesis, and it's pretty good for percussions, for metal sounds, and for like really experimental textured sounds. I love FM synthesis. Also, this snare is missing. I will add more stuff. Maybe I will add two impacts. For example, when I try to build like kicks, if you want like these kicks that are like really in trends in trap music, stacking up sounds help a lot to make that boom, 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 that are pretty.
So here, like if instead of using like, that 1000, like if we put an envelope in the cutoff frequency, like if we put a percussive envelope.
Yeah, or a line that will help also.
Yeah. Okay.
Yeah, for example, let's try it. Why not?
Yeah.
Because I really like that idea. Yeah, that's what I will do, like for my, like if I wanted to do like a real snare for a real composition.
Oh, so you would put a line. Okay, you would put just a, okay.
Yeah, because line,
like a quick line. Yeah,
line, it's more, in that sense, it's easy. Well, a next line to make it, to make the glissando.
And why wouldn't you put just an envelope, like just a percussive envelope?
No, that will help too. That will also work.
Yeah. Okay.
Yeah, but
you're right. Yeah, let's try like something. Yeah, just something different.
So I will do like from 2000 to, I don't know, 800. So a lot upper than the 1000 I want, and it goes a little bit down. And I want all these to be happening in the 0.5 seconds that actually last the snare sound. And basically that will be all that I wanted. And let's hear it. It sounds a little bit better.
Can't really remember how it sounded before, but yeah, that sounds good.
Yeah, it doesn't do that much of a change, but just to make it like super obvious, I will do like this.
Yeah.
Now you can hear it, right?
Yeah.
But that's too much, right? But maybe I can go up to 3000 just to make it cool. Oh, I like this one. Because that actually, the reason a lot of snare drums and a lot of kick drums has this type of glissando in the cutoff frequency is to imitate the impact of the membrane, because when you hit the membrane gets all tied up and it's a lot higher, and when the membrane relaxes, it gets lower. That's why I can even go further with this and put it like this. I like this a lot.
Yeah, it's cool.
It's cool. So it's better. Obviously, we can go and do a lot better snares. Also, depending on what snare you want, because well, usually the ones I made tend to be a lot more like in the EDM or trap type of stuff. So they are a lot more synthetic, because that's like the aesthetic. But sometimes if you want to do, for example, something that goes better with boom bap or with rock, you want something that sounds more natural. Or you can even go further and use samples and then modify the samples. So there's a ton of things. In class 6, we're gonna see how to sample and how to make things with actual samples that we get from the internet or we take from actual recordings.
Very cool.
But yeah, I like it. So let's use this one. So I think most of us are back. Yeah. So let's begin again.
So, sorry, Michelle, the samples is in which class?
6.
Okay.
Just to give a general, because I forget to upload the syllabus. I'm actually gonna do it now because I think it was Pepe or Daniel. I'm not sure who of you asked me for the syllabus and I keep forgetting. So I'm gonna do it now just to, well, to avoid forgetting it again. So let me see, this is in here. No, maybe here. Here, here, I go. There we go. Okay, so basically just to remind that next class will be subtractive synthesis and graphic user interfaces. Class number 5 will be FM synthesis. Class number 6 will be buffers, samplers, and granular synthesis. Class number 7 will be MIDI protocol, MIDI controllers. And in class number 8, we'll do routines, and we'll do like a composition exercise using synthesis, p-band, and routines, and using all type of synthesis we've seen into the class. Actually, we're gonna do a little composition exercise by the end of the, they asked me if I know the SCAMP software. No, it says no. Haven't heard of it.
No, it's a Python system to compose scores and to control Super Collider via Python system. It's developed from somebody from Stanford, but there was some information in a forum.
Oh, that sounds pretty cool. I will look at it. Actually, I actually learning Python, so it will be pretty cool.
Scamp.
There is
It's like a simple automatic musical controlled by Python or algo así.
Okay.
There is I don't know if you have seen it, a course on Coursera it's called like music processing with Python. That is the teacher is from Barcelona, but it's the content from Stanford, from Julius Orion Smith, like is the reference in.
Do you know the teacher from Barcelona? It's not Sergio Luque?
No, if he was, I think I might now be confused, but it was also called Michel. But let me check it and I'll tell you right now.
Okay, yeah. I just
sorry, how are the Coursera courses are very completed, or is yours introductory?
This one is, I think, is fantastic. The only thing is that you need to have prior Python knowledge. It's not like a course on Python. It's a course on
music in Python.
Yeah.
So you have to know Python very well.
More or less, but probably NumPy or some libraries. Here it is.
Yeah, but my question is, the Coursera courses are introductory or have a level like this workshop in SuperCollider?
No, it depends on the course. This one particularly is pretty complete, and it goes to a lot of, I mean, it's not like oriented to the live production, live programming to the
Yeah, I understand.
Yeah, real time.
But yeah, more for processing. I sent right away the link to the The name of the professor is Javier Serra.
Cool.
Michelle, can I speak 1 minute to him in Spanish?
Yeah, well, let's do this at the end of the class.
If
first,
you
please.
want, we can talk
Okay, okay.
later. There is no
Yeah, don't
problem.
worry.
Yeah.
Yeah, sorry.
Yeah, Morgan,
Yeah.
if you can send
Yeah.
the link, and that'd be nice.
Yeah, because I like the topic, but this is kind of a robust topic, P1, so I want to have time to go.
Sorry.
Don't worry. So, okay, so P-Vines, as you can see, well, this is basically all the P-Vine or the pattern, because they are actually belong to this class called pattern, as you can see, stream pattern events. And they all start with the letter P. Actually, this one bind from is because it binds patterns in the same event stream. So basically, P-Bind is like the carcass, no, carcass, that's not the word. It's more like the SINDEF or like the rack for patterns. So P-Bind by itself doesn't do anything, just like SINDEF by itself doesn't do anything, but it contains the other stuff that actually do it. So it says that P-Bind combines several value streams into one event stream. Each value stream is assigned to one or more keys in the resulting event stream. It specifies a string of events in terms of different patterns that are bound to different keys in the event. The pattern bound to keys are referred to as value patterns, and the P-Bind itself is termed an event pattern. So let's get a little theory behind this. For example, I have this sound. So I have ta, ta. That's a sound, just a simple timbre, but it's not a musical event. If for example, I want that's a rhythm, and that also has a dynamic, you know. So it has some accents and some rhythm. That's a musical event that needs the same sound to be outputted several times in certain order, so with certain durations. So if I go taka taka ta ta, that will be like taka 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 ta ta taka taka ta ta taka taka taka. If I'm in quarter notes, that will be for 32 notes and 60 notes per beat, for example. And I would require the last 2 notes of each beat to be higher in dynamic, so I have that accent, right? So that is a pattern that I want to repeat over time. So I make a sequence of music, and I will be needing which sound I'm using, which durations I'm using, and which amplitudes I'm using. So those 3 things in this case will be controlled. Each one of the parameters will be controlled by a pattern event. If, for example, I have a melody, I will be dealing with frequency or with tone in the melody. So I will go a little bit easier on this. So as you can see here, the keys, these keys are just the names that you can put to each part of the pattern, are usually determined by event default mechanism and the control defined for the SINDEF to be played. So it says that the keys, basically the parameters that you can modify inside your P-Bind are determined by the event default mechanism. For example, duration doesn't behave the same way as amplitude. And the controls, basically the controls are the arguments that you define in your SINDEF to be played. Because P-Binds, what P-Binds do is that they play SINDEFs in time. This is like the default syntaxes for a P-Bind. If I run this, I actually will hear sound. This is weird because I know SINDEFs don't do that, but P-Binds, if you run an empty P-Bind, because I have an empty P-Bind, it will run with like default settings. So first of all, it will choose an instrument, a SINDEF. By default, it will choose this SINDEF called test. That basically is a pulse generator. Also, if you can see, it's choosing a frequency. That's an A, 440 hertz. And also it's outputting a rhythm, ta, 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 that's 1 bit per second. So it's a quarter in 60 BPMs. 2, 2, 2, 3, 4, and 1, 2, 3, 4, and 1. Obviously, it's not making the accent to actually be in a 4/4 bar, but it's outputting that 1 per second beat. That basically has the coincidence to be a 60 BPM. So by itself, it's doing a lot of things. So let's choose the first thing that we can choose, that is instrument. That's the first thing that the P-Vines will always ask us. Basically, which SynthDef you want to be played. So to my snare, I will use my snare, so I will add amplitude to my snare. So we can modify that in the future. That was pretty loud, so I will put it like this. That's better. So the first one, so it will ask for a key. Remember that keys are these names, so I have to put instrument. If you go here in P-Vine, you can go a little bit and see here. The keys used in a P-Vine are determined by the SynthDef use and the structure of the extensive default mechanism provided by events. This second provides a pre-reputable. A SynthDef assigns a name to an interconnection of unit generator to be run as a synth on a server. This is basically the definition of SynthDef, right? It also assigns control names to the synth control inputs. In the following example, the synth test has control inputs out, frec, amplitude, number of harmonic span, and gate that are here. Our snare, it just has one control input, that is amplitude. The SynthDef needs to be downloaded to the server upon which it's to be run. Use add instead of send to ensure that okay, that doesn't matter. An event, this is important, is a dictionary that specifies an action to be taken in response to play and a time increment to be returned in response to delta. This is gonna be clear in the future. Events can be written as a series of key values pairs including parentheses. Empty parentheses create an empty event. So by default, events place synths on servers. Such node events use the following keys. So the first one is instrument. So we're gonna just get instrument, and we need to put, in this case, we're gonna use a snare because this is the one that already exists. So first the key that I want to use, and then which one I want to use. And I run this. So now by default is making a sequence. By default, the duration is in 1 bit per second. So if I go here a little further, this is delta, the time until the next event in sequence of events, generally specified indirectly to dur. So duration could be the one that works with time. So we're gonna only deal with dur for a little bit because it's the easier one. So I choose dur, comma, because then I will, that is the structure, what I want to modify and with what I want to modify. So duration, I will put 1. So if I put 1 in duration, that will mean basically what already was sounding. If I change duration to 0.5, that will be every 0.5 seconds will be a hit or 2 hits per second. So this will be like octave notes. Taka, taka, taka. If I put 0.25, I will put 60 notes. Taka, 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 taka. Taka, taka, taka. And here I can get 32 notes. Taka, 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 taka. So here I can pretty easily control at least that sequence. It's not the most fun part in the world because it's just a normal sequence that doesn't change rhythm, but I can control it. Up to this point, is there any question? Cool. So now this is a good moment to remember that mgen has this thing called done action. I didn't show you this in envelope classes because in that time it was kind of scripting why it was important. Now it will be more obvious. If I go and I use this code s.plot3, remember this is calling server, and this will show me this. This is the local host node tree. Remember that local host means the server. So basically what this outputs me the state of the server. Nodes synth definition create nodes. So look what happened if I run this. If I go command dot, everything disappears because actually command dot or control dot is not a off button, it's a free all in the server button. If I put a more fast number, my server start to curl up with snare nodes. Why happened that? Because basically what pbind does is that it's calling this synth. Pbind is doing this. It's telling snare to be played every time second. So it's just running this function like this. And if you go fast, obviously it's very difficult for me to actually go with command enter and output a correct rhythm because keyboards are not good for rhythm stuff. But the crowd, you can see that it's start to crowd. See? And they don't go away. They stay there until I free the server. Why this happen? If I do this, I put x equals my snare. And then I put x dot free. I free this one from the server. If I do this, then I can do it. I just can free the last one and the other one doesn't have variable at all. Why is this important? Because if I start to crowd the server, if I have a whole composition and all the compositions are leaving silent synths in the server, sooner or later, my server will crash because it will run out of memory. Why happened that? Because even though this is snare drum stopping sounded because actually the ambient take its amplitude to 0, the synth is still running because I didn't free it from the server. So that's what when ambient gets its chance to shine because it has this done action. And it says that it's an integer representing an action to be executed when the amp is finished playing. This can be used to free the enclosing synth. See down for more detail. If I go for down, I can see here the integers that can accept. If I put 0, that's actually the default. It says do nothing when the UGen is finished. 1 is 1000 closing synth, but do not free it. 2 is free the enclosing synth. And then they get a little bit more sophisticated. Free both this synth and the preceding node, or free the synth. If the preceding node is a group, then do give free all on it, else free it. And you can get all more and more sophisticated instruction. But for now, we can go with 2. That is basically free the enclosing synth. So if I go here, now I'm in gate. So one option will be gate 1, level scale 1, level bias 1, time scale 1, and then put 2 in the action. But that usually is not the best option. The best option is just I can type which argument I want to modify, put the 2 dots and directly and on the action. You can see that I jump it to the action directly and put 2. If I do this, now when the envelope ends, when this envelope ends, it will send a message to the synth to free itself. And now look at this. So now if I run this, they are freeing itself by the end they stop. So that will avoid to curl out my server. So basically, this done action is kind of mandatory. I mean, it's not always, but usually it's mandatory in our SynDevs that will be used as a percussive finite envelope objects or timbres.
Sorry, Michelle, the number 2 in besides done action, what does it mean?
This one.
No, in line 36.
Yeah, exactly.
Yeah.
It represents that because done action accepts integer numbers. If you put 0, then it will do nothing. If you put 1, it will pause the scene but not free it. If you put 10, it will free the enclosing scene. So it's basically the instruction you want the SINDEF to perform once the envelope is ended.
Wait.
Yeah.
Oh.
Yeah, please tell me, Quentin, that was?
Sorry. Yeah. Why this done action is put inside this envelope OEN? Because like, let's say, you create a synth without an envelope or whatever. So, I mean, you're still gonna have you're still gonna create like a synth ID. So, but I mean, I don't understand why this done action, is part of the envelope and not part of the actual synth definition.
Yeah, usually for example, envelope is not the only OEN that has those done action. For example, playbuffs. Playbuff is the object that runs WAP files or I files. Also has an action because it's waiting for your file to end. Usually, you will need an envelope in your SINDEF, because if you create a SINDEF without an envelope, it will make a click when it begins and when it ends. So at least you will need one of those HDSR envelopes that are waiting for an instruction to make the release happen.
Right. And so
lines also have done action. A lot of objects that are finite. Yeah, tell me.
So it's a bit, okay, I get it. It's a bit weird because so we are putting that kind of global action which has an impact on the synth, but it's not really an argument of the synth def. I mean, I would have expected that this done action to be part of the synth.new, for example.
Yeah,
an argument of it.
The problem with done action is, for example, here I have 2 envelopes. Imagine I have a sound that has, I don't know, 10 envelopes because I have a lot of parts of the sound. So then the non-action to which envelope will fall.
Right. Okay.
So now I can choose the specific action that actually triggers the scene to be freed if I want to free it. Because maybe I want it to be paused for a bit because I will send it a signal to be reactivated in the future because of my algorithmic structure. So maybe
so when you
maybe it doesn't fully make sense, but it's very useful, these done actions instructions.
So when you do this, you also free the envelope 1. So the envelope 1 is also going to be freed at the same time. Because I mean,
it's not that the envelope is free, but it's actually this free is like the synth definition in the server. Because actually this envelope ends before. If I put the done action to this one, and that was a good question, it will happen something pretty weird. Look. Did you notice it? Because this envelope sends the done action first, then it doesn't let this one ends.
Oh.
Because by
because
by second 0.25, it sends the free synth and it doesn't fully end. So usually you only need one done action, and it has to be on your largest envelope.
Okay, but it doesn't really matter where you. I mean, okay, get it. So wherever you put the done action on an envelope generator, it will have the same. I mean, it's just gonna kill the synth,
Exactly.
Later,
it will kill the synth in the moment,
Okay. And last question. So because right now, whenever we play the synth, we're gonna create like a synth ID. So why is that? And so would it be more efficient to actually just reuse the synth ID that we used before? So is there a way to, instead of creating like a new one every time, to right now, like the last one is like 1344. So instead of creating like 45, etc., can you just call back? What's the point of having a synth ID if we cannot reuse it? Like down the road.
Because the why you do this is because if you were like creating the same like new synth ID with different variables, then you will be able to on the fly modify them. In a snare drum, it doesn't have no change because the snare drum ends, but in a more large sound that you can change arguments like frequency and everything.
Oh, okay. So that's
why the
idea for.
Yeah, that's why SYNTH you do that. Also, another option instead of do action is, for example, to send all the snares to a group and then just send an instruction to the whole group to free all in the group. That will also work with using another class called groups.
Okay, and so in an actual composition, or like a longer composition, you would use those IDs, so like 1344, 1343, you would use those ID to call the different scenes from, you know, like so from inside a function, you could call like a scene using just this ID, and, you know, like change the parameter or this kind of
Exactly,
stuff?
exactly.
Okay,
Exactly.
okay.
Exactly. Yeah. The snare is kind of not so useful in that way, but if you put it on action to the snare will be working the correct way.
Oh yes, because okay, you can generate like as many snares as you want, so they're all gonna be part of the snare, like, you know, class, but with different ideas.
Yeah. So also, for example, Xline, I think it has its own on action too. Yeah. As you can see, Xline also has on action as an argument. So a lot of classes that work with like finite lines or envelopes work with on action.
Okay.
Yeah. So yeah, I think it will make more sense in the future.
Okay.
Also, that's why I didn't show you this whole non-action stuff in the envelope class, because it's pretty confusing until it makes sense. So I will go back to my snare. So I have my snare here, and it's happy and it's running. For example, now we are getting this failure in server. And this is pretty common. Most of the time it panics people. Basically, let's see what's happening. What is happening is that my P-bind is trying to output a snare sound for the duration of 1 second. My snare frees itself by 0.5 seconds. So for the rest of the 0.5 seconds that second lasts, my P-band doesn't find the node on the server, and it panics and it tells me failure on the server, the node doesn't found. But for me, I don't care about that because it's actually outputting the sound that I wanted. So for now, we're gonna ignore that failure in server. Obviously, if I put a more, for example, these are like, now the error doesn't happen because it actually has enough time to take to the next event before this is free. So, but if I put 2 seconds, it will be more obvious. Because it calls snare and it creates a node. But because the node frees itself after 0.5 seconds, the rest of the duration, that is 1.5 seconds, it doesn't find the node. And this is why it throws me this error. So it's more like a silent error that doesn't affect us, but it's just to know, it's good to know why it's there. So cool. So now I have this, we're good to go. But what if I want to use sequences? I don't want to be just like taka ta ta ta. I want taka taka ta 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 tun ta ka ta. I want to change rhythm. What I can do? All these keys that I'm gonna use in the P-bind accept patterns from the pattern family. So I'm gonna introduce you to our first and most used P. This is like the first child of patterns. This is a class that comes from stream event patterns, that is a pattern and it's a list. It basically says that it cycles over a list of values. The repeat variable gives the number of times to repeat the entire list. So here, I'm gonna copy this. Instead of hard coding this 0.5, I can use a PSEC. If I open PSEC, PSEC asks for 2 things. I want a list and I want the number of repetitions. So I give it a list and I want to repeat this 1 time. So I want this to do ta ta ka. So that will be ta ta ka. So just will be a hit and then 2 hits at double the speed. This is my list. So look this. And it follows my list. If I give it 5 repetitions, actually, this is doing something weird. Two times.
Michelle, and how we can change the envelope each time the pattern sounds?
The envelope of the synthet?
Yeah, the volume of each pattern,
Okay, I'm gonna go through this in a
each note of each note.
yeah, I'm gonna go in a second to that.
Okay.
So now I have this. If I put, so here repetitions, if I put inf, that will repeat to the end of the times. So there we go. So let's say that I want that pattern that I just told you. Taka, 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 taka,
What?
taka. Yeah.
What is inf?
Inf is, instead of giving a finite repetitions, like if I put 2, it repeats 2
Uh-huh.
times.
Infinite, okay.
Infinite. So I just put it there and I'm just shutting off with command dot. So yeah, inf is just a shortcut. Yeah, tell me.
Faster? You must change 0 to 25.
Yeah, if I want that, I want that
Faster.
rhythm that I just tell, that taka taka ta ta taka taka ta ta taka taka ta ta. So that will be something like this.
Oh. Why you don't change line 51?
Why I don't what?
Line 51,
This one?
duration.
What?
To change it into 0 to 25.
Here?
Yes, repetitions are faster.
No, you mean this?
Yes.
Yeah, but now I want taka taka ta ta.
Okay. Okay.
So I want taka taka ta ta taka taka ta ta. So I want 4 32 notes and 2 60 notes. So I want this because I want to hear taka taka ta ta taka taka ta ta.
And if I want to change the number for per, sorry.
For what?
And if you want to change the number for black note.
Yeah, yeah, okay. So now we are thinking that 1 is 1 second, so it's like a quarter note, not black note. But yeah, I understand you. In Spanish, it's escuela negra. But I can change the BPM. But I will show you how to change the BPM in a bit. So now basically this I'm giving this in seconds. This is an octave of a second. So this will be the same as doing this.
It's the same.
Yeah, because what Collider will be generating
1/16. Taka taka ta ta taka taka ta ta.
Yeah, those are
And 1/8.
Like this. Here, this one and this one.
It's
because I'm dividing the octave like this: 1 and 2 and 3 and 4 and taka taka ta ta taka taka ta ta taka taka ta ta taka taka ta ta. So I'm putting four beats in the first octave and then 2 beats in the second octave. So it's 4 32 notes. That's fusas in Spanish, and 2 60 notes. That's semi-fusas and then fusas. But yeah.
what is the tempo?
The tempo is I'm in 60 BPM. So the rhythm that I'm looking for is basically, if I have my quarter notes, I'm looking for this tempo, for this rhythm. Let me make a better color out of this. The rhythm that I'm looking for is this. taka taka ta ta taka taka ta ta taka. So this
No,
represents this
it's,
represents.
it's 8. Taka, taka, ta, ta. It's
Yeah, taka
no,
taka
it's-
ta. It's
no,
taka
no. It's,
taka ta ta.
delete this. The second line.
This line?
Yes, delete it.
No, because this all is in one bit. It has to be like this.
Mhm.
Because if I delete this will represent a quarter, and I want this whole to represent a quarter. Taka taka ta ta taka taka ta ta taka taka. That's actually that's sounding. So these are 1/8 notes, and these are 1/4 notes. Because this equals to a quarter note.
Yes.
So basically, I'm dividing this. If I divide 1 by 8, I get this number, right? And if I divide 1 by 4, I get this number. So
If you have 16, then you have semifuses.
no, these are semifuses.
So if you have,
Because-
but if you put 16, then you have the division in eights.
If you put this,
Yeah.
that will
Yeah.
be that will be 16 notes per bit. So you want semifusas is 8 notes per bit.
Okay.
So this is the division to have 8 notes per bit.
Okay.
So I get the rhythm. And you can use whichever of the. Sometimes it's easier to use these ones because if you are working with like round numbers, these are pretty cool. But imagine you want to do a 7 tuplets. So 7 tuplet is a really weird number. So it's really weird to type 7 of this if you want like repetitions of, or if you want, there are also, for example, triplets. Triplets are also a weird number, right? Because when triplets have like this infinite correlation to divide by 3 or by 6. So yeah, I have the rhythm. This is the beat. So yeah. Now imagine that I want the accent because I want taka taka ta ta taka taka ta ta. And so now I have to change the amplitude. So I can use as a key whichever argument that I have on my synth.
Sorry, Michelle. One answer. I didn't understand the question. If you put 3 is triplets, yeah?
Yeah.
Okay. Yeah.
Yeah.
Sorry.
If you want like taka ta taka ta tika ta taka ta, that triplets, you need 1 divided by 3.
Okay. Yeah.
Because here I'm just dividing by like the quarter note by the actual note that I want. Or if I want to fill a quarter note, I will need 8 1/8 octaves.
Okay.
So yeah, so I can use as an argument, I mean as a key, whichever argument I have on my synth. So I have amplitude because I define it here, right? So I can go here. I'm gonna copy this one just to have like the steps because so you can follow this like step by step in your house. So I go, well, you are on your house right now. You get the idea. Amplitude. So for example, if I just put a number, all the notes will follow the same amplitude.
Michelle,
Yeah.
if you want to use four charts, for example, for 4 sequence at the same time,
Like one after the other.
like 4 instruments with snare.
We're gonna get to that. That's actually the last part of today's class.
Okay.
Yeah. I'm just going step by step. So if I change this, for example, if I put a number, all the notes will have the same amplitude. And if I put another PSEC, then I can also make a list for this. So if I put, for example, this, basically the p-line works by events. So it says, okay, first event, which instrument I will use? Okay, snare. With which duration? Okay, 0.125. With which amplitude? 0.1. Event number 2. Okay, snare, this duration, this amplitude. Event number 3, snare, duration, amplitude. Event number 4, snare, duration, amplitude. And event number 5, snare, duration, and amplitude. So I have
Taka, 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 ta, ta.
exactly, and it sounds like this. And now I got the accent that I wanted. Obviously, here I have 6 rhythms and 6 amplitudes, so they will have a correlation. But what happens if I have 5 amplitudes and 6 rhythms? So they will be a dephasing, right? Because this will be ending with this. So this will be with this, and this with this. So they will be a dephasing of sound, and it will sound kind of like those Steve Reich compositions. Like you're really minimal and really changeable. So here, every step, every 5 notes, the accent is moving 1 note to the left. Yeah,
It's loop.
yeah, it's a loop.
It's a loop.
It's kind of like a polyrhythm, but with the accent.
Yeah, because the accent is always falling in a different, 1 beat apart from the other. So it sounds pretty cool. Well, I will leave it with the normal beat accentation. Huh?
Yeah.
So now I can generate all type of, for example, I can go, I will leave the amplitude like in a normal way. And I can do something like this. I can put like a rhythm that isn't that straightforward, but still loop through a different rhythm.
Can you do, Michel, similarly, can you do a probability of trigger? Like, you know, it's very, can you do, so it's pretty common, like in in the modular world. So, you know, like when you sequence, trigger sequencer to have a probability of trigger. So, you know, you want to keep the same, same beat, but you don't want it to be triggered all the time.
Yeah, you don't want to be like looping through a,
Yeah, so you want to miss like a, like a quarter note or whatever. Or like,
exactly. Actually, what we're gonna do, I'm gonna show you more examples, and the final exercise of today will be a beat that it's following a 4/4 bar, but it changes its phrases all the time. So we're gonna go through this point. So I'm gonna take 1 minute to go to the bathroom, and then we continue. Sorry, too much coffee.
right.
Sorry, I'm back. I try to be fast as possible. So, yeah. Well, I see a couple of people that aren't back yet. Well, I get everybody back. Is there somebody has a question about regarding the place we are now? Cool. So, well, before showing you, because now I'm going to show you another type of piece, because we are just dealing with sequencers, but there are pieces that deal with probability, with randomness, with distribution, with Fibonacci, with Poisson, with, yeah, they're like, I don't know, there are tons of them. And that's why it's so powerful, this method of algorithmic composition. But before going there, I'm going to show you how to use sequence, like use patterns inside patterns. So for example, here I have 4. And here I have 2. So this could be a sequence itself. So imagine I take this one. And instead of writing 0.125 4 times, I can modify that and transform it into a sequence itself. So when this sequence starts, it will go to a sequence that will repeat 0.5 4 times, and that goes to the next numbers. And also this one, I could make it a sequence itself. So these two are equivalent because this is going through the numbers, and this sequence is going to a sequence that repeats this number 4 times, and when it ends, goes to this sequence that repeats this number 4 times. And it's sequence.
Sorry, Michelle. Sorry, I have a question.
Yeah.
Sorry. This,
Don't worry.
Disculpame. 0.125 is equal to 1 divided by 8.
Yeah, it's a semifusel.
Okay, sorry. Yeah, okay.
Yeah, don't worry. Yeah, you will get used to this, to start thinking musical times in numbers. It will stand to be natural. Just thinking this, if you have a quarter note and you want it by semifusels, that means that there are 8 notes inside 1 quarter. So that's the division you have to make. So if I run this, it will sound the same.
Cool.
So this is pretty cool because you can put sequences inside sequences, right? And well,
Michelle,
yeah.
Can we do the same in line 85 amplitude? P-sec.
Yeah, of course. Yeah, we can go here. Yeah, and actually this makes a lot easier to read stuff for like to know what you compose, right? Because also we'll make a correlation. For example, if I put here the comma. So now I know that these 4 will sound with this 4 and these 2 with these 2, right? So this is the same as this, but a little bit more organized. I'm missing something.
You have a big space in comma, it's necessary?
No. The big space was just to make like an alienation, but you can do it.
I can understand.
Yeah, to make it more clear which was.
Yes, understand.
Yeah. In general, supercollider doesn't read spaces. For example, if I do something really crazy like this, and I run it this way, it will still work. Supercollider don't mind about blank spaces. It doesn't read it. Supercollider separates stuff with commas and semicolons. So for example, even though I can even do this, for example, if this appears to me like more organized, for example, like this, it will work. For example. So now I know that the sequence is playing the sequence inside of it. So it's just a matter of how you visually want to have your things organized. Because spaces doesn't affect the code.
Το μάθημα σήμερα
Yeah. Yeah, well. So now, yeah. So it's kind of clear this, yeah, annotation stuff. So let's then do a new, I will take this one. You're muted, Panayotis. If you're trying to ask something, I can't hear you, but I can see you talking.
Okay.
You were trying to say something?
No. I speak to my wife.
Ah, perfect. Yeah, don't worry. Yeah, mine's here too. Okay, so, well, let's do, instead of this PSEC, use a different type of P. The second P we're gonna learn today is one of my favorites, Pirand. So this actually also, it's a pattern that works with lists, but it says that this one, embed one item from the list at random for each repeat. So instead of cycling over a list, it will throw you at random one element of the list.
Michelle,
Yeah,
there is a P stochastic,
yeah,
not random instead of stochastic.
yeah. They are random, stochastic, or ones which work with Poisson, with probability, with Brown, with Fibonacci. There, you can use conditionals. You can go pretty quickly, pretty crazy with P's.
With P.
Yeah, with also the ones that work with Fibonacci, with P numbers, with whatever you want.
Okay.
There's even one called P-func that actually performs a function every time a pattern happens. So you can put like really heavy mathematical stuff in there also. So Pirand, it asks for the list. So in this list, I will put quarter, octave, 60 note, and a 32 note. And I will put it. So it's choosing at random. I will put more random numbers in there just to make it more interesting. And then I can put at the end of the P, I can put this called trace. It's similar to in Syndex to poll. So it will output in me real time the decision that the Pirand is making. Very cool, right?
Yeah, Michelle. And if you want to have two patterns at the same time with SNAR, to have more than one node at a time.
One that more, well, you need to activate both patterns.
To have counterpoint.
Yeah, well, the easier, there's a ton of ways, but at least for today, we're gonna use this, like the primitive way that is just running them at the same time. So I'm running it at the same time. This is not the best way to do this, but for today, it's okay because later on, we're gonna learn about routines and PT parts that organize patterns in time. So let's, yeah. So now I want to show you using another instrument. So we're gonna use this bell. This was the bell that we made last class, remember?
Yeah.
I'm gonna put, I don't know, 15 of these.
I didn't
Well, what? Can you repeat that?
I didn't understand what does it mean the n variable. The tilde n equals 15.
This is a global variable that we can change the number of harmonics with this number. It's just a variable, but it's globally.
Okay.
Yeah, I actually that isn't necessary. This was just I'm not sure who asked that, like a more advanced question, and I used that to illustrate something.
Yeah. Okay.
Okay, so I'm gonna I like that one. So I have my bell. So I'm gonna take this and go here. And now I'm gonna go with bell A. For duration, I will put 0.25 and for amplitude 0.2. So I have this, right? But now my bell has the argument frequency, right? So I can, I erase my stuff here. So now I can use, for example, frec. So I can go psec. I can go with something pretty simple, like just like really way sense scale. That's pretty cool. Or it also can add stuff there. I put a PRAN instead of a psec. Make it super quickly. And just by that, I get something quite interesting.
And can we put round p round in duration?
Yeah. Yeah, you can get pretty crazy here too, PRAN. Also, well, I'm gonna show you two stuff. First, I'm just gonna put, I don't know, some different rhythms in there.
And also random frequencies. It's not necessary to write 100, 200, 300.
For PRANs, yes, because PRAN works with a list. What you want needs another object that I'm gonna show you in a couple of seconds.
Oh.
Yeah, but I like that you get to the next step. I like it. So first, I'm gonna show you this. So it sounds pretty cool. I'm gonna copy this one so I don't erase the code and you have all the examples. So yeah, the problem with PRAN is that PRAN asks me for a list. I will put a constant duration in here, but I can use this called pwide. It actually outputs random values with uniform distribution. So here it doesn't ask me for a list. It does for low and high. So it will send numbers between those two numbers. So if I put 100 and 1000, it would send random numbers in that range. Obviously, it wouldn't sound as tonal, as pleasant as this one, because the relation between these frequencies has a rational plus times 2 times 3 times 4 from the fundamental. This will get very crazy all over the spectrum. If I put trace here, I can look at which frequencies it's choosing.
And if you make the same into the duration.
Yeah.
And,
If you make-
and amplitude, yes.
Yeah, if you make same duration, then you get Boulez structure composition.
Mhm.
Boulez,
Yeah,
huh? Hmm.
yeah,
Yes.
he has like this piano that used with random.
Yes.
Yeah,
yes.
I'm just. Mhm. Yeah, actually, a lot of this stuff was like pretty intended for 20th century randomly algorithmic composition, right? Actually, if I put the trace to the whole p-vine, I can see how the p-vine is choosing events. And I will put another p-white in here just to make it a little bit more interesting.
Yeah, if you want to
Yeah.
to have temperate frequencies between p white, is it
Yeah.
possible?
I will tell you in a second.
Okay.
Yes, so that's like music for changes.
It's better to make amplitude 0 to 0.1 and after 0.5.
That's a question or what?
No, try it if you want.
Yeah, to make amplitude.
No, amplitude 0.01.
Ah, yeah, to make it drastic here, of course.
Yes,
Yeah.
yes. More drastic, yes.
Yeah, and now I can see how actually the p-vine takes decision. So first event was, you can see here event stream, instrument bell A, duration 0 point, this ridiculous number, amplitude, this number, and frequency, that number. And you can see that it was changing duration, amplitude, and frequency each event, choosing always the same instrument because that was hard-coded.
And Michelle, if I put instrument / Bella plus snare, what will happen?
I think that just plus, I'm not sure if that will work. I haven't tried that anytime. No, it doesn't work. But there are another type of, if you try, you can do this in another type of ways. So that's until that time, it's pretty cool. So you can get like pretty random pretty quickly. So now you asked me for how to make this work with a temper scale. There are several ways to do this. I'm gonna put this stable so we can like go more in depth to the what you call this with the frequencies. One, there's like tons of ways, but yeah, one will be we're gonna have a class about MIDI, but did you know how MIDI numbers work for notes?
MIDI.
Yeah.
Yes.
Yeah.
From 0 to 127.
Yeah. Yeah, I want to make a really quick because we're gonna have a whole class for this. But just to make a really quick for this. So. So I'm gonna draw here an octave, the worst octave ever. So I have an octave here, right? So imagine this is the middle C in your piano. So usually, no, not usually, that middle C in MIDI is represented by the number 60 in MIDI numbers. So having this as a point of departure, you can very quickly define the other ones. I'm not sure if you are good with pitch class or just with intervals. We know that a perfect fit up from 60 is 7 semitones. So this is 76. Or 11 semitones, that would be a major 7. So that will be 61. I mean, 71.
Seven.
Yeah, if I want a minor third, that's 3 semitones, so that will be 63. If I'm a perfect third, I mean a major third, that's 4 semitones, so that will be 64. If I'm a minor second, that's 1 semitone, so that's 61. So you can like cover your whole octave like this. So that was 61, 62, 1, 2, 63, 64, 65, 66 for the tritone, 67 for a perfect fifth, and so on. Obviously, I'm thinking the intervals from the 60, that is my, in that way, I'm just like learning by memory this number and just defining the other ones by interval theory. So if I go to SuperCollider, I can go here and put, for example, 60, 64, and 67. This in midi numbers will be a major arpeggio, C major arpeggio. Obviously, 60, because frequency is getting frequency, 60 isn't as. So you gotta go 60.MIDI CPS. This is a method that transforms my MIDI number into cycles per second. And you can see that I got, for example, this. For example, if I put 69, that corresponds to the middle A, I will get 440, that is the middle A. So I can put here dot MIDI CPS and get that. If I want, for example, to change to put this an octave lower, I can just put -12 at the end of this, so that will be an octave lower. And also imagine I want to transpose this. I want this to be, instead of C major arpeggio, I want to be a D major arpeggio. So I sum up 2 semitones to each one. So this will be 62, 66, and 69, and it will be D, F sharp, and A, and I get a D major arpeggio. So that's why that's what I say. If you want to write in MIDI, just learn the 60, and you will do transportation by getting, for example, if I do to be if I put -1, then it will be a C, B major arpeggio.
And if Michelle, and if I put, sorry,
Yeah.
if I put minus P white and 12 to 20, 24 P white,
you want to change that number every time?
The transposition of the scale.
You want the transposition to be algorithmic.
In line 141.
Yeah, I think
instead of -1, minus P white.
Yeah, I'm not sure if that will work, because I think you will need a P key, but let's see. Maybe it works. I'm getting crazy. 1 up to 10.
Yeah.
And let's do this. I don't know. Let's see if this works. Now.
Yeah.
Let's see. Maybe I need to put this in parentheses. No, but there's a way to do this. There's a way that this actually works the way you want it.
Okay.
But you need extra steps.
Okay.
I will go to those steps in a moment. So, well, besides that, is there any question up to this point? Any question?
I didn't understand very well the concept of MIDI SIPs.
Basically, this transforms a MIDI number into the frequency that it represents.
Okay.
Yeah, if you can see, if I run this line, it's basically send me, because it's 60 minus 1, it's 59. It's giving me the actual frequency of the MIDI numbers I put. Yeah. Because my instrument frequency is my instrument clank is working with frequencies.
Yeah. Okay.
So yeah. So give me a second. I'm coming back in like 1 second. I'm back. Sorry, I have to check something. So I'm back. Okay, so now, sorry for the interruption. We have, well, less than half an hour, but we're gonna use the half hour complete because we lost a little bit of time at the beginning of this. Yeah, so I'm gonna show you another P object, and then we're gonna use what we already know to make a little exercise composition, to make a little beat. We're gonna use bell, a snare, and also I'm gonna take 2 synths that I have pre-made that we're not gonna make in this class just to avoid losing the time. We're gonna look to this in another class, but we're gonna use them to have more timbres to work with. So we're gonna work with one of my favorite objects, a piece that it's called PWRand. Because this one actually works with probability. It says that returns one item from the list at random for each repeat. The probability for each item is determined by the list of weights, which should sum to 1. In probability weights, it's like the probability of one event to happen over the other. This comes from the idea of the weighted dice. When you have weighted dice, the dice has more probabilities to fall more times in that number. So I'm gonna take, to illustrate this, I'm gonna take one of the snare stuff. Yeah, come here, snare. Snare, yeah. And we're gonna go to PWRand. So in the list, I'm gonna put 1, 0.1, and 2. So this is my probability. It's like a quarter note, a white note, or a half note, and this really 0.1 note that will represent a note from a really small note. So here I got the weights. I need to put a number that represents the weights. And here it says that by a list of weights which should sum to 1. So my weights, my total weights should sum 1. So for example, I will put 0.8, 0.1, and 0.1. If I sum this will be 1, right? So I have like 80% of 1 happening and just 10% of this and this happening. I put if, and then I go trace. And I forgot a comma. So you can see that we get almost only ones, here a 2, then 1, 1, 1, 1, 1, 1, then a 0.1, and then a 2. Because this was a devastating 80%. If I go and I change this, and I put the 80% now to the small note, so it's still random, but now it's really a well-directed random to the place I want it to be. And this is pretty cool in that matter. And also, I can take this a step further. And instead of just giving it plain notes, I can give it patterns. So for example, I want to be triplets, quarter notes, and 60 notes. So I can put a PSEC that makes 8 notes. So this represents 1 quarter. One that represents 60 notes, so represents another quarter. And that one that represents triplets. So basically it can do these 3 figures. It can do taka or taka taka or tikata. but randomly. So it will always hold off in place of 1/4. And I will go and put equal distribution to everybody. I can even put like 30%, 30%, 30%. And here I can make a trick. That's called normalized sum. This normalized sum will change my values to its same proportion to what to sum to be 1. Normalize. I put it math. Normalize sum. There we go. So you can see my 33 is transforming into 0.233. So they in conjunction sum 1. So I run this. But I forget to normalize sum, so it wasn't taking my to account yet. And you can see that it never follows of tempo because each one of these P6 represents 1/4. So you can see it goes tick, tack, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. This is a tempo. So it's just choosing between these things. This is kind of clear or not that clear? Cool. So now I have, I have my bell. I have my my snare drum, and I will take these two synths that I have pre-made it that we're gonna go through their to their actual how you call this synthesis process in next class, because today I'm just trying to make it so you can use it. So don't worry about that for today. So I'm gonna take this. I have this hi-hat that I pre-made, but actually, if you can see, it's a pink noise that is just filtered and with a really short envelope. And I had this kick that I made with a little bit of really simple, how you call this, additive synthesis. So super simple. So let's build something that can work as a beat together. So I'm gonna use those real drum kit and my bell. So I go here. Be minds. We're gonna end this class like 3:15. I mean, 15 for me it's 3:15. For you with like 10 or 1, I don't know. But instead of ending at the 3 hours plus 15 minutes, because we lost a little time at the beginning of the class because of my delay, and we chat a little, doesn't matter. Just I want them to be, if somebody has to leave at the actual hour, don't worry, just leave and you can see the last part in the video. I mean, it's not mandatory, just for you to know that I want to like cut it exactly in time. So we're gonna use instrument and call this bell A. For duration, I'm gonna use, I'm gonna just for my melody, I will just make a straight melody that works in a loop. So I have like a bass, and on top of that, I will make algorithmic drums that are changing algorithmically, but my melody will be the same, like to have like a really loop, like steady beat, just like when like hip hop beats, you know, the melody is the same all the time. So we go like this. Why hip hop? Because easy to make, it's rhythmic, it's like it has like really easy directives to follow. So duration, I will go something like this. Also, this is the first time I show you this rest. So rest represents a duration, but with silence. So this will take the duration in silence instead of make it. So it will be like, if I put this will be ta, 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 ta. So here's it's just a silence. This is the way to make silence using this like rest and put it in parentheses the time you want to be silent. So for frequency, I will use again a PSEC because I want this to be steady. And I will just put something, a really simple melody in, I don't know, something in minor, so something like this. So this 60 will represent this, and this 60 will be silent. So I'm representing because it actually will choose, the rest will choose a frequency. So it needs like a dummy frequency to choose, right? So then I will put 63. And 64, 62, and 60. Something super simple. And I just put dot MIDI CPS and stable amplitude. And let's hear this. I like it, but it's super slow. So it will change the tempo clock because also you asked me how to set that. So here in play, I can put an object called tempo clock. So here it asks for, I want to be faster. I want to be at double speed. So that will be 100 over the 61 that is like in the, so this will be a double the speed. Tum, cla, tum, cla, tum, tum, cla, tum, cla. Something like that could work pretty easily with that beat. So that's what I have the snare, the another one, and the hi-hats, right? So that works pretty cool. I like it. I will leave it like this, the most simple. Now the other ones I want to be algorithmic, to be changing with probability the possibilities of choosing stuff. So here I will choose, I'm putting the .com at the end because I will run things together to make it sound at the same time. Like I said, this is not the most elegant way, but this is like the first class that we did everything with command dot. It's just a way to avoid confusions for now. When we learn routines, we're gonna get to the next level in this. So instrument, I'm gonna use the hi-hat that we had. And for duration, we're gonna use a PWRED because I want this to be algorithmic. So for this, I go like this. So I'm gonna organize this in a way that makes sense. So for the hi-hats, I will put different sequences. Why will I choose sequences? Because every one of these sequences will correspond to a bar. So basically, each bar, each 4/4 repetition bar, it can choose a different rhythm. In this way, I'm assuring that my hi-hat will never get out of beat. So the first one, I want just to be playing wire notes, the typical. And I will do the same here. Basically, I want that to do all the time, but now I want to have possible endings. You know, normal trap do like these rolls, like this that they really work. So I can put here, I can put inside here a PSEC doing only 6 numbers, and then I can put a roll. For example, just one of these rolls. So this is well programmed, yeah. So this will be, the first one will be, the second one will be, so I can repeat that process. and this one, but this one ends with a triplet. And this one ends with a roll doing 8 notes. Like super fast. So this is 8. There we go. So now I will need probabilities for this. I want this to be the most prominent probability, to stay on that most of the time. So I want to do this be 4. Then I will give 20 to the second one. And that leaves me with another, 25. So that's 65. I'm leaving with 35, right? So I can put like 20 and 50. If you ask something, because I can't hear you. I see some, no? Okay. And now I will put normalized zone. This is important because it needs to be number. If I run this, my numbers will be transformed into its correlation, so they sum 0, as you can see. And I mean, they sum 1. Then for the amplitude, I will put, here I put 8 amplitude. I know that sounds pretty crazy, but that's because I'm using a ping noise that doesn't have that much, not much power in the higher up frequencies, and I'm filtering a lot. So that's why I can use the 8 and isn't that bad. And basically that's all I need for my hi-hat. Let's hear it by itself. Of course, I'm missing the tempo clock that will make it go at the speed that I really wanted. So it's now we're following the same, but it's getting on the same page all the time. If I put it with my bell, it works cool. My bell is a little bit up in the volume, so I put it a little bit down. So now let's add our snare. Basically my snare, I wanted, most of the time, I wanted on my third beat. It's because I want something like that. To be hitting most of the time in that beat to get that like late of trap feeling. So I'm gonna put here snare.
So, sorry, Michel. Normalize some. What does what do it does?
It transforms all these numbers accordingly to a new proportion. So the sum of all the numbers is 1.
Okay.
Like
Okay.
this. So you can see it changed the 40 to 0.4, the 25 to 0.25, and so on.
Yeah, because they don't sum 100.
Yeah.
I mean, this is technically a Markov chain, right? So, I mean, it's
This
just,
one?
it's a Markov chain. This idea is
My PW run?
Yeah.
Yeah, but no. The reason why it isn't a Markov chain is because Markov chain remembers the last decision to take the new decision. Because remember, Markov chain, if you go to like this decision, then you only can go to these ones and not the other ones. And this is always taking in account all the decisions, but it's going in that matter of Markov chain. Actually, there are p-bines that use Markov chain. So I like that idea. So I'm gonna use this snare. At the end of the, when I end, I will go a little bit further with normalized sum just to make it clearer. Yeah, because you asked. So well, I will go, I can use this, but I can change a little bit this. So for the snare, I can go, well, the snare, I will put it in a more, like the snare, I will put it in 0.3 amplitude. And the sequence, the first sequence I'm gonna make is rest 2, 1, and rest 1. So that's basically 1 and like the normal one that I wanted to be making, right? So that's 1 repetition. Then this one, I will put it like this. So that will be and another variation will be 1, and so I'm assuring that the 3 options fall in the 3rd bit, but they changed a little bit the idea. So they're kind of the same, but not the same. So I get variation. Obviously, this will get richer when it starts to, because I have 4 possibilities and 3 possibilities. So it can be possibility 1 with possibility 2, possibility 1 with possibility 1, 2, and 3. So it expands the possibilities algorithmically. So for this, I will go pretty quickly and put 50, 25, and 25. I can hear this. It doesn't sound pretty cool because we don't have like the beat going on in our head. But if I go with the 3, actually, I want this to be louder.
So if I want that all the instruments sounds automatically, I enclose this in a parenthesis.
Yeah, exactly. Like
Okay.
I said, there's various ways to do this, but for now, this is the easiest way. And it sounds cool. So now I will add my, also I can work with panning and make a little, but let's just work with the kick now. My kick is this one. It's not the best kick, but it works. I can take this structure, put it here, put it kick. And for kick, I want my kick to be on the 1st beat most of the time. Then I want to be silent for 0.5 seconds, and then just take another hit in the last beat, in the last counter beat. So that will be like tum, 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 something like that. So because I like how that sounds. So then I will make something like this. So that will be just like tum, 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 tum. So we can have like variations of that stuff. This will be always in the first, also in the first kick, then to rest, and maybe a variation in the last one. And let's make someone that doesn't fall on the 1st beat, just to have that surprise sometimes, because that also is kind of strappy to have like tum, 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 kla, tum, tum. It sounds pretty cool. And so I will just put this, and then a rest, and then a beat. Yeah. So I need to change this. So I want this, the first one, to be the most prominent one, and then maybe 20, 25, and 25, and then 10. So I have a little bit of variation. So let's hear this with that. I like it. I will put it like really high, because that's also part of trap. It has to, kill your speakers. I like it. So let's hear all this together. And just to add the last thing, I will copy this other instrument that we're gonna see later also. Here, I like this instrument. I hope just to copy like this. Just to add a little bit of more melody to this. Well, more. So this is a bass. This is one of these basses that are called 808. It's like boom, boom, boom. So let's hear it. Like. So this is just a bass. So I'm gonna put I just need to copy this and call this 808. I just want this to be 2. And I just want the frequency to be psec to be 60, something like, because I wanted to be this minus 24 to update lowers, to be like the fundamental of what the bell is doing, right? Let's hear this. Yeah, let's do something pretty simple, but it will sound pretty dope, I think. I go a lot. Oh, I got to the last 2 here. Obviously, these aren't the best sounds. They are all of them are pretty simple. They don't have panning, they don't have reverb, they don't, but the idea is to show the idea of how I build the algorithmic, because every time I run it, I get a different entrance. Also, if I change, for example, my possibilities to be a little bit more equal, so I take out a little bit of stability out of my stuff, because this will take out stability and will add variation.
If I want to use, for example, the hi-hat, not p round instead round, I have to delete the line 222. So yes.
I will show you in a second.
Okay.
Yeah, I'm just like giving it more variation. Also, I will give this the possibility to go and choose to get a little bit out of beats the bass, but not so much. Like with this, inf to choose between 1, 2, and 0.5. Maybe that's too crazy, but yeah, let's see what happens. Just to see that I can get it a little more less stable and more. So yeah. So your question is, I had the hi-hat here.
Yeah.
And you want to do it what?
Can you, yeah, instead of using PW rand, probability rand, used rand.
Yeah, well, for rand, I can just like erase this. That actually putting PW rand with all the possibilities being equal, this is a P rand.
But if I want to use rand, I have to delete one line, yeah?
Yeah, you can go like this. Well, one option is if you want just like to run the same stuff, you just need to take the probabilities, and now it's
only rand, not P rand, instead rand.
Yeah, I put P rand now.
Okay.
And now it's like this, right? Obviously, if I wanted this to be more rand, I can change like this and give it, well, normal numbers like this, right? I don't know how much randomness you are looking for.
Yeah.
Yeah, obviously, also I can change this to be like a really aggressive tribe. If I change this a little bit, a lot.
Can we have a global tempo?
Yeah, Let me show you this and then I ask you. And then I change the tempo and I get a total different feeling. So that was Fotis. Yeah, or who asked?
Yeah.
You mean, what do you mean a global tempo? If I change one number and change everything?
Yeah, like this. Like change the tempo of every instrument that there is, of every.
Well, there are various options for that. Like the most easy, or like the one that I could, without making that much fuss about, is like put tempo equals 180, for example. So, and then I change this to everybody. So now they will respond to that global variable. And I just need to change the global variable and I will have everybody responding to the new tempo. So if I put tempo, I think 180 is craziness. That's almost like a psytrance beat, but let's see how it goes. And I can go pretty quickly and make it, for example, slower, right? We'll be just changing tempo because now they are responding to that variable. So yeah, that will be like the faster way to change. But there's are better ways to do this because actually this is not like a normal beat used to work. Normal beats used to work more like this. They have like an structure, right? You start to hear the bell first, like. For example, I have an example here. This is a more advanced, but I can show you just how it sounds. So here, because this has all the P lines, but then it has a routine that actually modify the entrance and the out. So it has a structure. Not everything is like running in parallel. It just lasts like 3 minutes. I will show you like 1 minute or two. Let's just hear it. It's also on that some things stop, some other things go on, and yeah, it's a lot of stuff.
Question, Michel.
Yeah.
So do we have like a master clock? Because if you start, at different times, so how do you make sure that they're all in sync with, each other? So do we have like a master clock, like in the modular world?
Yeah, that's one option. Here, what I was using was a smaller trick because this routine was running at 120. So I know that my seconds means 2 bits. So if I put 2 seconds, it's 1 bar. So 16 is
okay.
8 bars and so on.
But do you have, yeah, sorry, go ahead.
But there's a way to put a master clock and that's better. Because if you are at 135 bits, it's very weird to count seconds like that.
Yeah, like for for example, I see like if you have a master clock, like, you know, it's gonna start like at the nearest, at the closest, you know.
Yeah, the clock,
actual
yeah, you
peak
can
of
do
the
that.
clock.
Yeah, you can do that. And that because there's actually a way to, there's a p-bind, there's a pattern that organizes patterns in time, like a master p-bind.
Yeah.
Yeah, here I'm using a routine because here was for another class that we were learning about routines. So
you can wrap like several p-binds inside.
yeah, inside
global
like a
p-bind.
master. Yeah. Also here I'm using another thing called p-mono because I don't know if you noticed, but the melody has a little bit of delay and a little bit of reverb, and that was controlled by p-monos. That because that means when you an effect, you don't want an effect to be outputted in triggers like a pulse. You want an effect to be a monophonic event changing over time, and that's where p-monos enter. Also, did Zoom outputs you this in Panet? Or did this bit was outputted to you in stereo? It was like a mono mix, double duplicated.
I don't remember.
If you don't remember, that means that it wasn't outputted because the hi-hat was jumping, the snare it was really well panned. If you will notice it, I think that maybe Zoom is making a mix and just send you the mix. It's not sending my. But yeah,
I think it was mono, but yeah.
Yeah. So yeah, well, but basically that was the idea. Also, this was also an example using all these simple synthesis devices, because you can get a lot better results if you are making more complicated synthesis and if you are using samplers and everything. Also, why I'm choosing hip hop or pop stuff, because these have really clear rules of how they should behave, and they are better for effort. If we want to compose a really experimental, texturized, electroacoustic, stochastic, it's super easy with SuperCollider. It's even easier than doing the beat. But it's just, if we can do the beat, we can do something experimental. Also, because we can throw randoms and algorithms and stuff. So it just goes step by step. Because the problem if we're doing like really experimental stuff is that you are not really noticing if it's making what you want. And with something that is really tight, you have the idea, okay, it's making what I want, then I can go crazy to experimental stuff. If you are, yeah.
Michelle, if you want to put charts in a simple instrument, in a single instrument,
you want to put what?
If you want to, if I want to make charts in a single instrument.
I don't get it, that word. Chords, chops, chops.
Chords.
Chords.
Sorry.
Yeah, don't worry.
In a single instrument.
Yeah, I didn't show you that, and that was on me. Sorry about that. I will take my bell.
For example, the bass, the bella.
Yeah, the bell is better for chords than the bass. Well, the bass, yeah, but the bass, because it's like a really, that bass, as I was trying to do it like a 808. That's a real, like a hip hop term that is kind of a mixture in between a kick and a bass.
Yeah, it's drummer.
Yeah, it's kind of drum. They actually take name from for a drum machine that was really popular in the 80s and that stuff. Yeah.
Ableton Live.
Yeah, obviously Ableton Live put you with as 808s. Yeah, because Ableton Live is intended for beat production. So if I go here, I want and I just have to put. I will put like constant duration. I will, and here I will. You just have to put things inside. Inside
like collections.
Yeah, collections, and it will put it together. So I will just do this. So it will be 62, 65, 69, and then this will be 762 again, 67 and 71. So that will be a a fair fundamental.
To repeat the times.
Yeah, it's just a progression.
Okay. The first collection is the first
Yeah,
chord.
yeah, this is a C major chord, this is a F major chord, and this is a G major chord, just to make a 1, 4, 5.
Yeah, okay.
So this
Thank
is the way you put chords. Also, I can make this random, of course, and then choose between those chords randomly.
Now we have algorithmic counterpoint.
Yeah, and also you can use conditionals. So I can put, for example, I can put my chords to be random, and I can type a base that is checking which chord did my piano choose. So my base is always choosing the fundamental, for example.
Machine listening? That's machine listening?
No, not machine listening, because it's just using conditional. It's like, if they choose chord
Okay.
1, I choose this number. It's more like correlational, normal conditional switch multiplication. I will show you that later, or later in the classes. So, well,
Okay.
I think I go a little bit further, but up to this point, is there any question?
No.
Obviously, with P-Bands, you can do things that are a lot more, like I said, more, you can do ambient, you can do real experimental stuff, because remember, it depends on the syntax. Here I choose only like percussive, but I can choose like a really weird instrument, percussive instrument, or a really texture instrument. So, for example, we're gonna do some synthesis to make like noise and sounds textures when we go through FM. Or actually, this 808 has a little bit of FM, so yeah. So yeah, so well, basically that was like the idea. Let's put it in, I don't know, 130, just to sound it, because that's a more hi-hat. Yeah, obviously with a little bit of reverb and more production, it will make better. Obviously, also I will use better synthesis or better samples for the, especially for like the kick, and that sounds, the kick, it doesn't quite goes to the real that we are intended, but it doesn't matter. It was just an example, and it was trying to make the best out of using only the elements we have used in the last 3 classes. P-Bands are really cool class, and yeah, I hope, yeah, you can go through this. What I recommend to do is take these instruments that I leave here, take the kick, take the snare, take the hi-hat, and take the melody, make the 808, and do your own patterns, and try to build your own composition, and make something, maybe, don't make, maybe make something that sounds more like rock, or maybe sounds something like sounds pretty different, or maybe just make a to make like a house beat, I don't know, or make something really crazy, like really algorithmically, really complicated. But
I have a final question.
Yeah.
For me, can you go? Yeah, there, up, down. Yeah, there, line 218.
This.
When you put prand, why you don't have to put pbind inside the values of random in line 222? Why do you don't have to put pbind?
Another P, because this has the
psec, sorry.
Because this is here prand is choosing by individual elements. If you want psec, it's because you want prand to be choosing between individual sequences. So here prand is choosing individual numbers. If I put psec, it would be choosing between sequences.
Yeah, okay.
Yeah. So here it can say or 1 or 2 or 3 or 4, and with sequences like here, it will choose the whole sequence. What I'm doing with sequences is that I'm assuring that it doesn't go too crazy and doesn't go out of my 4/4 bar beat that I wanted to create, but that's not like a must.
Yeah, sorry.
Yeah. Also, for example, you can add to the, for example, to the hi-hat here. This is a hi-hat? No. This is a hi-hat. Snare. Where is my stuff? Bill,
Down.
no, I think I erased my stuff.
Okay.
There you go. Yeah, I erased my, sorry. Here's my hi-hat. This is the last thing and we are finished because yeah, it's pretty late. Sorry about that. If I can put here a P white in the amplitude and going through, I don't know, through 4.1 and 8. This will help if I try to make a more humanized sound, right? That also helps. Why I didn't do it in the trap beat? Because in trap beat I want like this really like almost digital sound, like impossible sound. But if I'm trying to achieve a more natural percussive sound, then changing amplitude, it's so cool. Also, another trick will be like make me 5 different hi-hats that are pretty similar to each other, like hi-hat 1, like 5 synthesis, and choose here different, like put a P run in the instruments. So it's also changing a little bit the timbre and that type of, I will show you these tricks in later, but I'm just like giving you random tricks.
Michelle, and this P rand and P rand and rand P white can be controlled by Arduino?
By Arduino, they are controlled by itself. But yeah, I can make that. I can make a trick that my P bind is receiving information from Arduino and changing. Yeah, you can.
Sensor.
Yeah, you can do that.
You should give me private tuitions.
Yeah, of course. Yeah, of course. I put in my Facebook page. I didn't know you see I'm making a installation with plants and Arduino.
Yeah, Michelle, I really like that at the end of the workshop, we arranged to make a private courses.
Yeah, perfect. Yeah.
Okay.
Also, there's also, I think it was Morgan, I think, because that the one that was the really complicated question of maths, that he's also really interested in Arduino. So maybe we can arrange at the end a session, like a session, like a general session, and then your tutoring. So we can arrange something. So, but yeah, of course.
I'm not going to take the second workshop because I'm going to take a Stanford workshop in Scamp.
Yeah, don't worry about it. Yeah.
But I will pay you for the classes.
Of course. So, well, this is class 3, Saturday, May. Okay, so yeah, we are past the time of the class, but I wanted to like end this session. P-Binds is one of my favorite class sessions because it's really musical. There are a lot of others that are pretty more, for example, the next one that is about graphical user interface. It's a little bit more, because we have to build windows and buttons and functions and to build like an interface. But it's really cool because you are starting to interact in real time with your synthesizer without using plain code. You can use like this BST. So is there any other doubt, question, complaint, or whatever?
Yeah.
Tell me.
In the next classes, are we gonna go into connecting a super collider with stuff outside of it, like Ableton getting signal from plugin from Ableton and getting it into super collider and then using it?
Well, at least in like the only thing that we're gonna see, I'm sorry about that because of the sessions of the course, is how to control MIDI controllers, how to control super collider with MIDI controllers, and also how to send MIDI from super collider to Ableton, for example.
Oh.
Yeah, for example, by MIDI loop.
Exactly. And I can give you, well, in the second course, I have a whole session for OSC communication, but if you're not going to be in that, I can give you some examples of how to use OSC. For example, I use my remote controllers to control super collider. That's by using OSCC protocol. I also
that's very interesting.
Yeah, I'll also use my Arduino. I also use a lot of stuff. So yeah. If you want to connect softwares, between them. Super Collider is the one to go. Also, my girlfriend is a visual artist, and she's doing like some stuff with visualization and sonification of data. And we're using Super Collider as the master organizer of data. We're not making any sound with Super Collider. Super Collider is getting the data, processing the data, and sending to Notch to make the visuals and to Ableton to make the sound. So yeah, we can totally make that. Because this is the cool part of Super Collider. It's a really robust programming language that can do a lot of things. Sometimes I say this is kind of a joke, but it's real. Usually with Super Collider, the answer is yes. It's just how we do that. But the answer is, I want to have plans and microphones sending data, and then I want to send the data to Touch OSC and then data back, so I make the sound. That's possible. It's just how complicated is that? It can be a couple of weeks to solve it, but you will get to the answer. So cool. Any other question?
Yes, Michelle. As we're going to see graphical interfaces next session.
Yeah.
Is there any way we can print data from Super Collider, like the sample rate? Because I've been trying to figure out how this LF noise 0 works, and it mentions sample rate divided by, I don't remember what value. And I've been trying to print these values, and I haven't had any kind of response.
But you want,
only print objects.
But you want to use the sample rate of your own Super Collider, or I'm not fully getting the idea.
I was trying to figure out how this LF noise worked, and in the documentation it mentions that it's a division between the sample rate. It doesn't specify which.
Okay, yeah, now we get it. I can go to next class at the beginning. We can go through that question because it's
okay.
It will take like 10 minutes to get to the whole explanation. It's something really simple.
Okay.
Also, I can give you a little bit of theory behind what sample rate is and how to manage your sound cards and everything. Yeah.
Okay, but through the graphical interfaces, we can see values that belongs to Super Collider, right? When we try to output some data, we don't have any means to see it, because the only form it expresses is through audio, right?
But you want to see the data of Super Collider? Yeah, we can see it. We can see it through the graphic interfaces itself. For example, just like I will show you very quickly this. If somebody just has to go, it's okay. Don't worry. For example, this is a graphic interface, right?
Mm-hmm.
And for example, if I go through here, I'm seeing data here, here, and here.
Okay.
This data represents the fundamental of that sound, the violin. Then I'm looking at the spectrum by magnitudes here. And here I'm having different harmonics and superharmonics by doing a multiplication and a division, and I can modify that in real time.
Okay, that's what I meant.
Well, that's very cool.
Yeah, and you can get very crazy with GUI.
Michelle, could be helpful to read this book, okay?
What? I'm not seeing it.
Are you seeing my screen?
Yeah, Super Collider book.
Yeah, the chapter number 6, Event and Patterns, were by Ron Cuivilla. Can it help me to understand further about the patterns that we see in this class?
Yeah, I think it would. And also try.
Or it's very difficult to understand.
No. I myself, I'm not the kind of guy that reads books. Usually for programming, I just start programming like crazy, and I get more experience myself by doing stuff. But yeah, reading the documentation helps a lot. Also, if you already have like some experience in programming language, it's better, because that book that you have, it's kind of a high level stuff.
No, because I have background in programming.
Yeah,
still
yeah,
computer science.
Yeah, it will help a lot. It will help a lot. It will help a lot.
Okay, thank you.
Yeah, so cool. So well, that was all for today. In a couple of hours, I will post the the video and the patch also in Facebook and in the Google Classroom. So next class will be more subtractive synthesis. We'll go through more filters. We'll go to resonant filters, and we'll go through. So that was all for today. Sorry about the extension at the end of the class, but it was just like to take. Usually the next classes are not that long because it's just like building syntax and stuff that we already like well acquainted.
And the video is usually uploaded to YouTube, yeah?
Yeah, the video will be uploaded today. Yeah. Because but for some of you we are near changing the day, but here it's gonna be 4 o'clock in half an hour, so in a couple of hours. Yeah, I will upload the video. And remember, the whole videos will be through the whole duration of the course and a couple of months extra. So you have enough time to go through the videos, do your patches. I know that sometimes I cover a lot of information in the 3 hours, and it's not because I want to get you crazy. It's because I want you to give as much information, and then you can go through it pause me, copy the code. So get a whole spectrum of how Super Collider works. So see you next Saturday. Have a good weekend, have a good week, and have fun.
Bye-bye.
Bye, thank you.
Bye, thank you.
Good night for the ones that are good night, and
Good way to everyone.
see ya.
Bye.
See.
Bye-bye.